Welcome back. We're going to do problem 10, and then I'll show you one of the ways of doing the bonus. The velocity function in meters per second is given for a particle moving along a line as v of t is equal to this. So we're moving along a line here. So the velocity at time t, so we have some particle, whatever, it's moving one of the directions at a given time. That speed, that velocity, is 2t minus 5. And recognize for the velocity, its direction, this is not just speed, but direction as well, comes from the positive and the negative. When it's a positive number, it's moving to the right. When it's a negative number, it moves to the left. So this particle actually begins its time at time 0 moving to the left. Now, if you think about what is this, you're going to add up all of the different velocities, velocity rectangles. Maybe just think about, you can think about this in a couple of ways. The answer here is, what is it going to represent? It's going to represent displacement. So where is it? How far has it gone? What's the distance between its ending point and its beginning point? Let's say it that way. Now, you could think about this a couple of ways. Velocity, if it's speed, you're thinking about distance per time. That's your units. dt is a time unit, so in the end, you end up with a distance unit. So you have some sort of measure of distance, but in this case, it's not the total distance traveled. It'd be this. Now, if I did something like the absolute value, that might give me total distance, but this right now is just displacement. And so feel free to explain that in more detail on your test correction write-ups. How you might convince somebody of that fact of the matter. Sometimes you could draw the graph in 2 dimensions and sort of see how time and distance relate to each other. All right, so for this one, let's actually find it. So this says, hey, just take that integral. It told you what it was up above. Let's do it. Recognize the 0 and the 4 give you the bounds there. So this is t squared minus 5t. 0 and 4, I get 16 minus 20, so negative 4 minus 0. That's meters. So this tells me, in the end, I'm 4 meters away from where I began after 4 seconds. And then what is the distance traveled during the time interval? So distance here means the total distance that you traveled. So what happened? So for a while, you're traveling to the left. How long was that? Well, that's whenever v of t is negative. So let's think about 2t minus 5. When is that equal to 0? Well, that's equal to 0 when t is 2.5. So for the first 2.5 seconds, you've gone to the left. For t from, so this is 0 less than t less than or equal to 2.5. And then you go the other way, right, for 2.5 until you get to 4 seconds. And at that point, the total distance that you've moved is 4 meters to the left. So if I want to know what's the blue length plus the blue length, right, those two added up, let's find out how far what's the furthest I went? Well, that happened at the end point of my leftward motion. So that would be 0 to 2.5 of the same thing, which we've already done up above. So this is really just saying, take your t squared minus 5t and plug in 0 and 2.5. So when I plug in the 2.5, I get, I think, a negative 6.25. So it says the distance gone there is 6.25. And then we know the last second and a half, we go back 4 meters. So that would mean if this is 6.25, I go back 2.25 more. And so then the total distance I went is 6.25, taking the positive version of it, right? And 2.25. I want to make sure, we're doing the total distances. I've dropped the negatives here. So it would be 8.5. 8.5 meters is my total distance traveled. Great. Those are all the solutions. Let's just do the bonus real quick here. So you proved in geometry that the area of a triangle is half of the product of its base and height. So you have an area of a triangle, 1/2 base times height. So in particular, that we're saying then, if a triangle has a base that's 2 units long, if it has a height of 1, its area will be 2 times 1 times a half, so 1. So what, I'm sorry, I should just keep reading. So it'll have an area equal to 1 square unit if the remaining vertex is at the point A1. Because for any value of A, that's any value of X, the height for all these is equal to 1. So it could look like this. It could look like this as well. So the area of this, so I'm going to draw these two things. I'm going to say this one right here is, we'll call this one f of x, is this line. And we'll call this one right here g of x, or these two lines. Now, wherever you put it, I'm going to say what the integrals are doing. So, I'm going to add the areas beneath these, but sometimes there'll be an overlap between those two areas, and you actually have to subtract off the other one. Let me show you something that's really neat that happens here. So let's pick a place to put it. Without losing any generality, I'm going to go ahead and say that the triangle stands, well, I'll just use this one up here, where this is the point -1, 0, and this is the point 1, 0. So it's on my x-axis. And so I'd say the area underneath f of x, which would be this thing right here, is the integral from -1 to a, so those are the ends of the x values, under f of x dx. And notice in this picture right here, I would want to subtract off the g of x. So I would subtract off the integral from 0 to a of g of x dx. Now, what's cool and wonderful about math is that this is going to take care of all of our cases. So if a is over to the right here, this is a positive number, and I'm subtracting it off, which is exactly what I want to have happen. If you look at the first picture I drew, you might think, wait, don't I want to add these two together? Certainly, but what would happen with this particular integral as I drew it here is, well, if this is my g of x, if 1 is right here, then if I went from a to 1, this would be a positive value that I'm subtracting off, which would be a no-no. But I'm going from 1 to a, which makes this just a negative version. So I'm subtracting off a negative, which is equivalent to adding. So all I need to do for this one is to take this definite integral minus this one and show that that is equal to 1. And that's pretty neat. All right, so let's just do that. All we need to do is say, well, I guess we'll go over here to the left. I'll do it in blue. Let's just find the equations of your lines. F of x is a line. So the rise over the run. So it goes up 1 over a minus -1 times x. And it goes through the point x equals -1. So minus -1. So there's the equation of your f of x. So we could do that real quick. So integral from -1 to a of this stuff. I'm going to go ahead and pull the 1 over a plus 1 out in front because I don't need it. X plus 1 dx. This a plus 1 is coming along for the ride. I'd have x squared over 2 plus x, plugging in -1 and a. So when I do that, I would have a squared over 2 plus a. And then when I put a -1 here, that gives up 1/2 minus 1, 1/2 minus 1, so -1/2. Great. One thing I'm going to do here, a bit of a trick, is I want to factor this. Oh, excuse me. I said negative, but it should be subtracting off -1, so plus 1/2. I want to factor this. One way I could do that is I'm actually going to, excuse me, pull the 1. That was probably still loud for you. Pull the 1/2 out in front of that parentheses. And then in there I'd have a squared plus 2a plus 1, which is nice, I'll write like this, a plus 1. Let's just factor that. That'd be a plus 1 squared. So this whole thing is just a plus 1 over 2. Now if we do something very similar for the g, we would end up with 1 over a, well, I guess I'll give you the equation of g. Be 1 over a minus 1, x minus 1. So very, very similar. 1 over a minus 1, x minus 1. We're going to go from 1 to a, dx. All right, so same sort of things happening. 1 over a minus 1. We're going to have x squared over 2 minus x. 1 to a. All right, same thing happens. I'm going to pull out the 1/2. I'm going to plug it in and pull out the 1/2. Just follow the pattern. And we would be able to get, we'd have an a squared minus 2a plus 1. That's what we're looking for, which would factor to a minus 1 squared. So we just get a minus 1 over 2. So in the end, all we need to do now is this. What is a plus 1 over 2 minus a minus 1 over 2? It is in fact equal to 1. And there you go. It's a bonus, so it's a bit of a challenge. It can get a little messy, but all those steps are things that you have. You can do it. I believe in you. Live long and prosper. Sayonara.